right, let's briefly discuss simple harmonic motion. Because of their periodic nature, trigonometric functions are used to model phenomena that occur again and again. This includes oscillatory motion such as the swinging of a pendulum. Trigonometric functions are also used to describe various kinds of waves, radio waves from your favorite radio station, television waves, and sound waves from your CDs. So let's see what's involved here. And of course, these up and down oscillations are simply called simple harmonic motion. All right, an object that moves on a coordinate axis is in simple harmonic motion if its distance from the origin, d, at a time t is given by either d is equal to a times the cosine of omega t, and d is equal to a times the sine of omega t. A, the absolute of A, again, is the amplitude. In this particular case, the amplitude measures or gives the maximum displacement of the object from its rest position. And the period of the motion is given by 2 pi divided by omega, where of course omega is greater than 0. And the period gives the time it takes for the motion to go through, as you know, one complete cycle. All right, let's look at an example. A ball is pulled 6 inches below its rest position and then released. The period for the motion is 4 seconds. Write the equation for the ball's simple harmonic motion. All right, so let's see what's going on. A ball is pulled 6 inches before its rest position and then released. When the object is released, all right, in other words, t is equal to 0, the ball's distance, d, from its rest position, in this case, is given to be 6 inches down. 6 inches down, all right? Because it is down, then we know that what? D is going to be negative, all right? So D, since 6 inches down, translates into D being a negative 6. So notice the greatest distance from rest position occurs when t is equal to 0. All right, therefore we use the equation for the cosine function. So we have y is equal to a times the cosine of omega t. All right, this will model the ball's motion. All right, let's see what we have here. Recall that the absolute of A, all right, is the maximum distance. All right, because the ball initially moves down where A is a negative 6. All right, so, all right, A is a negative 6. The value of omega can be found using the formula. All right, so let's find omega. The period is going to be 2 pi over omega. All right, and what do we know? It tells us that the period for the motion is 4 seconds. So 2 pi over 4 is equal to 4. In other words, 2 pi is equal to 4 times omega. Solving for omega, we get 2 pi over 4, which is pi divided by 2. All right, so if we substitute these values into the equation, D is equal to A times the cosine of omega t. What do we have here? All right, the equation for the ball's simple harmonic motion is given by a -6 cosine omega, it's pi over 2, times t. So then the equation for the ball's simple harmonic motion is given by D is equal to a -6 times the cosine of pi over 2 times t. The last idea that we want to introduce is the frequency of an object in simple harmonic motion. All right, an object in simple harmonic motion given by these two equations has frequency f given by f is equal to omega divided by 2 pi, or equivalently, we can say that f is 1 divided by the period. Let's look at a couple of examples here. All right, here's an example. An object moves in simple harmonic motion described by the equation D is equal to 12 times the cosine of pi over 4 t, where t is measured in seconds and d in centimeters. All right, we are to find the maximum displacement. All right. All right, let's just denote what we have. We have D is equal to 12 times the cosine of pi over 4t, where, let's just record, A, the amplitude, all right, is 12. All right, so therefore, the maximum displacement from the rest position is the amplitude. And because the amplitude is 12, the maximum displacement is 12 centimeters. All right? That's part A. In part B, the frequency. The frequency, well, we define the frequency to be omega divided by 2 pi. All right, so in our problem, omega is what? Omega is pi divided by 4. So what do we have here? We have pi over 4 divided by 2 pi. Pi over 4 divided by 2 pi, this is going to be pi over 4 times 1 over 2 pi. So this is 1/8. All right. So the frequency, so therefore the frequency is 1/8 centimeters per second. In part C, C, you have to find the time required for one cycle, and I'm going to assign part C for homework. So, solve part C. If you have any questions, please post them to the discussion board.